different notations and ways in which a molecule can be given to you, so you know what to do and how to work with it. So first I'm giving you this molecule, okay? So it's obviously 1,2,3,2,3 dichloropentane, but we need to assign configuration here. This is a chiral center. Here we do have another chiral center. So we need to assign configuration to these two carbons before building the name. So I'm gonna say this is carbon number 2. So I'm gonna focus on this carbon. And what I'm gonna do is I'm gonna basically, and you can do this at home, redraw this carbon only, okay? And this, I'm gonna actually, so you redraw the carbon, I'm gonna copy this and paste, easier for me in the program. So this is carbon 2. As we know from the bond and line notation, anything that is not shown here, so here is a carbon, there is a hydrogen that is hidden there, and because it's not given, we know, everybody must know that the hydrogen is actually in dash position going away from us because that's the only option. So a carbon has 4 bonds. I'm giving you 2 bonds in the plane of the screen, 1 bond coming away from us, and the remaining one must be, sorry, 1 bond coming toward us, and the remaining must be away from us. Remember, this carbon is sp3 tetrahedral structure. So this is the configuration of the chiral carbon, and now we're going to assign priorities. So I'm gonna look at which groups are bonded to my carbon. So I see a chlorine here, I see a carbon, carbon, and hydrogen. So obviously chlorine will be based on atomic number, priority number 1, and hydrogen will be priority number 4. Okay, now I do have a carbon here, I have a carbon here, so that is a tide. So I'm gonna see what is bonded to each carbon. So this carbon here on the left is bonded to, and look, I want to emphasize you guys to look into the steps that I'm taking, and that's the steps that I suggest you to take as well. Do not jump steps because that's how you make mistakes. So in the left side, I have 3 carbon bonded to 3 hydrogens, hydrogen, hydrogen, and hydrogen. So obviously the highest priority here of these 3 is a hydrogen, and this carbon over here is bonded to chlorine, carbon, and hydrogen. So remember, when you have, when you're looking at a single atom, you look at what is bonded to this atom, and then from the 3 bonds that this atom will have, the 3 atoms bonded to this atom, you will look for the highest priority. That's where you will use to compare. Highest priority of these 3 is chlorine. Highest priority of these 3 is hydrogen. Therefore, this carbon will have a higher priority as the left one. So this could be now my priority number 2. And the left carbon will be priority number 3. Okay, so I assign my priorities 1, 2, 3, 4. And then next, I'm gonna make sure that the lowest priority group is away from us. The lowest priority is 4. It is away from us. So we are ready to read it. We are looking from the front. In this case, this is away from us. We are looking from here. 1, 2, 3. This is always clockwise. So this carbon must be R. And that's how we assign configuration. Now I'm gonna look at the carbon next to it. I'm gonna copy this. So the carbon next to it is this one here bonded to another carbon. This is a flat line bonded to another carbon. This is a flat line. These two are in the plane of the screen. Away from us, there is a chlorine. Therefore, we also know that coming toward us, okay? I'm going to actually put this a little bit better. So we know now that coming toward us, there must be a hydrogen. Okay, so now I have my tetrahedral carbon in 3D. The chlorine is away from us, the hydrogen coming toward us. Two carbons on the plane of the screen, 109.5 degrees. So now I'm going to assign priority. Obviously, chlorine will be priority number 1 here, and hydrogen once again will be priority number 4. Obviously, hydrogen has atomic number, which is the lowest in the periodic table. Okay. Now I have 2 carbons here. Okay. This carbon here is bonded to, and I'm going to repeat the same exercise. The carbon on the right is bonded to hydrogen, hydrogen, and carbon. So carbon will be the highest priority of the atoms bonded to this carbon, hydrogen, and hydrogen. So because of that, then what I'm going to use to compare in this case is going to be carbon because that's the highest priority of these 3. And then I'm going to look